All right, R1 sets. Sounds like we're talking about volleyball.
I know, I was like, what? Sets?
All right, so we're going to have a lot of definitions, a lot of like what symbols mean and stuff like that, at least in this like first one, since it's stuff that we haven't really seen before. So a set is a collection of objects elements are objects in a set. And then set braces are how we write a set. There's not really a better way to explain that. But they look like this. It'll take a little time to get used to drawing them.
Whoa.
It's just like a...
How we write.
It takes a lot of practice to learn how to write them, but as long as you just like make them kind of curvy looking, we're good.
Oh my gosh.
My left ones will always look better than my right ones.
Oh my gosh.
It's fine. It's fine. I promise it comes with time. All right.
Very good.
If you have, so this is going to be a symbol, and then we'll like a couple symbols, and then we'll go back to definitions. So if you have this symbol, so it's literally like a sideways U with a line through it, okay? That means element of okay, so that's how we would say something is an element of something else. If we have that symbol, but it's got a line through it like that, that means it's not an element of.
Oh, wait, no. That makes sense.
Sometimes I use these like notations, like when I'm teaching like calculus and stuff like that, and then it's like, they'll look at me and they're like,
What does that mean?
what? And then I explain it, and I'm like, oh yeah, because like that's not like a common like notation that most people would just know. And then just something else to note about like how we write things, we always denote a set with a capital letter. So if we're talking about set A, we're going to write it as a capital A. Okay. All right, so we're going to go back to some definitions, and within some of these definitions there'll also be a few more like ways that we write things like that. So if we have an infinite set, there is an unending list of elements. So with something like that, an example would be like all the numbers between 0 and 1. So if you did like 0, you're gonna have to draw it a lot. 1/2, 1/4, 1/8, and so on and so forth. Like that would be an unending list, so that would be infinite.
Oh, it's not too bad.
Kind of have those written backwards, but it's fine. They don't always write them in order anyways. It's easier to grade if you write them in order, but it's whatever. I always get annoyed when I like write them all and then I'm like, oh man, I missed one. And it's like you either try to like wedge it in or you just write it at the end. Because some people care. I don't care that much. It's not like the end of the world to me. So that's an infinite set, a finite set.
There is an
is going to be a limited number of elements.
I feel like a lot of these are very like says it in the name.
Basically. So example of that would be like 0, 1, 2, 3.
I'm so excited for lunch.
Me too.
Bro, same. I'm so hungry.
I'm
I have
getting
pizza.
chicken nuggets for lunch. I'm so excited.
It's getting better. This left one looks really snazzy.
My right one's always look better than the left one's.
All right, this one should be a review. Natural numbers.
Perfect.
Okay. Also called counting numbers. Okay, so the counting numbers are stuff like 1, 2, 3, and so on and so forth. 0 is not one of the natural numbers.
Let me guess the next word.
Okay, so another one of an infinite set would be if we had something like, so the natural numbers are an infinite set, I should say. Natural numbers, if we're talking about them in general or just like the set of natural numbers, we'll call it n, but you would do your bracket and you'd have 1, 2, 3, 4, and then if you just did ... that would just mean keep going. Obviously, there's no ending to when we stop counting. I mean, I would stop counting at some point, but they go on forever.
Unnatural numbers.
No. Set builder notation.
What?
So set builder notation uses a variable to describe elements of a set. So for example, if I had, okay, the set 3, 4, 5, 6. Okay, the way this would get written in set builder notation is X, and then this line, which means such that. Sometimes I will abbreviate that as ST. So if you ever just see me, I do it more in other classes. Well, I don't know. I probably will end up doing it in this class, but in other classes I write ST a lot for such that, just to like make life easier. But anyways, that's what that bar means. Such that X is a natural number between 2 and 7. So that means it's not including 2 and 7. So the universal set, it includes all elements. When you see it written, it's going to be symbolized by the letter U. So that's the one that includes all of them. Then we have the null set, or another name for it is the empty set. Most often I'm going to call it empty set, but they can be used interchangeably. They mean the same thing. And this is the set containing no elements. And it gets written as basically a 0 with a line through it, or just the empty set brackets with nothing in them. Okay, but very specifically, it is not that. Okay, this would be the set containing the empty set. So it's either this or this, not this. Okay, now occasionally you do have a set containing an empty set, but if you're talking about no elements, don't put something inside of the set brackets. Whoa, what? Hello.
Shoebot.
It's my Operation Christmas Child list. I don't even know how that just came up. All right. So then another thing of a notation, a subset, and I'll define it in a second, is symbolized by, okay, this is another thing that looks like a sideways U, but it has a line under it.
Oh my gosh. This is not it. These notes are so trash.
Yeah, we're not looking very nice.
So if we wanted to look at an example of how this would be written, okay, if we have the set, I'm just going to use S, the set 1, 2, 3, 4, okay, then we would be able to say that S is a subset. I'm telling you, these windows and these doors freak me out a little bit. I don't like that people can just walk by and just stare in the classroom and see what's going on. Like, I don't mind, like, Mr. Law, Mr. Fletcher walking by, but it's just, like, anybody else is, like, freaking me out.
Yeah, I know. It's distracting.
I definitely, like, have walked by, like, Miss Marshall's room a couple times and been like, whoa, because I'm not used to being able to see in her door.
Yeah, it's weird.
All right, so,
Kind of cool that we can like smile and like stare at it.
so S is a subset of N, okay, so of the natural numbers. So, definition-wise, what does this mean? I'm going to use some symbol or like some letters to like help explain it because it's the easiest way to understand what it means. But the set A is a subset of the set B. Okay, so I'm writing those as capital letters to write that they're a set. If every element of A is also an element of B. Okay, so would you agree that the numbers 1, 2, 3, and 4 are all natural numbers? Counting
Yes.
numbers. Okay, so then I can say that the set S is a subset of the natural numbers because all of them are elements of the natural numbers.
Correct.
And just another like random kind of fun fact, every set is a subset of itself. We use Venn diagrams
Oh, I don't like
to show sets. Okay, we'll do more with those later, but I'm assuming you've at least seen a Venn diagram, the thing with the circles that overlap
Correct.
at some point.
Yeah.
Do them in English.
Do you have Venn diagrams in English?
Yeah.
Oh.
Yeah.
These are more fun than that.
A book, and then but what they have in like.
Oh, yeah, that's fair.
We also do web, like math, web. What are they called? Webs.
Character webs?
Yep. Webs. I like webs.
All right, more definitions.
Oh my goodness. We only have 4 minutes.
I know, we're probably not going to finish, and that's okay. The complement is the set of all elements that do not belong in a set.
What? Okay, that makes sense actually.
So, this is written as a apostrophe, okay? We say a complement, okay? Or we'll say the complement of A. Or another way to say it that you'll hear me say more often because it just sounds nicer is A prime. My foot just got stuck. I was sitting here like, I cannot move.
These are the best purchase ever. Except that they're not gonna match many outfits, but
I love my Vans. Anything dark they'll go with.
Yeah, I love them.
All right, intersection.
You're gray.
If you have 2 or more sets, it is the elements that belong to every set. I'm gonna try to finish this little page of notes and then we'll stop. The rest of the stuff can wait. Okay, this is written A with an upside down U, B, and the keyword for this is and. So if you see the word and, think intersection. We'll talk more about these tomorrow, but I want to just get through these quickly. A disjoint set. There's no elements in common. So if you think of with a Venn diagram, okay, with disjoint, you can think of there's 2 circles, there's no overlap. Okay, they're 2 completely independent circles. With intersection, you're looking at only the stuff that overlaps, okay, that's in both. The last one, and where we'll stop for today, is union. So this is the set of all elements belonging to 1 or more sets. Okay, and then just so you can see this really quick, this is written A and then U, okay, B. So union, you can think of a normal U, and the keyword for this is or. So if you were looking at a Venn diagram, this is everything in the circles. So the overlap, the stuff that's not overlapped, it's everything that's in the circles would count for the union. But we'll look a little bit more at exactly what each of those 3 things are tomorrow, but at least we got through all the definitions today. And you should still have time to work on like homework problems tomorrow. So.